Hello, Matthews Gatos here. In this video, we are going to cover sum, difference, and double angle identities. Let's get started. Before we get into these identities and all the formulas, I need to make sure that you have all the exact value identities well under wraps. So I want you to know the exact values for sine, cosine, tangent, and their reciprocal functions, secant, cosecant, and cotan, for all 16 angles from 0 to 360. Now, whether you do that using the hand trick and the cast rule, placing your quadrant 1 angles in the correct quadrant and using cast rule, or using the unit circle, either way that you are using, you now have 6 ratios multiplied by 16 different angles. You have 96 exact trig ratios at your fingertips. So when I introduce these formulas, it's going to be even more trig ratios you can do. You can pick any one of those angles, add them together, and get an exact value for another angle measurement, or by subtracting, or by doubling. So let's look at the formulas. So there are 6 sum and difference angle identities: sine, cosine, tangent, add, and subtract. These 6 formulas are on your formula sheet. You don't need to worry about memorizing them. We just need to know which formula do we use when. Now you'll notice there are 2 new variables. Remember I said trig is a little bit of a snob? Well, it already has theta, which we've talked about, but now we have 2 new ones, which is alpha and beta. So these are the 3 common trig letters that are used to represent variables for trig equations. In addition to sum and difference, we have double angle identities. So we have them for sine, cosine, and tangent. Notice that cosine has 3 different equations. So why do I have 3? When do I use each one? They're all different derivations of each other. So the first equation, I would use that anytime I want to get rid of a negative cos squared or a positive sine squared in my expression or equation. I would use the second one anytime I'm trying to get rid of a positive one combined with the negative one would cancel. I would use the third one if I'm trying to get rid of a negative one. So when you're trying to decide which one you're going to use in your formula, just ask yourself, what would introducing each one of these formulas do to the existing equation? How would it help me simplify it? Then you'll know which one to use. Okay, let's try 4 examples. So we're looking at writing each of the following 4 expressions as a single trig function and then finding the exact value. Again, exact value tells me no decimals, so it's a nice point using hand trick or unit circle. So looking at this one here, I have a combination of sines and cosines and they are subtracted. I go to my formula sheet and I see which one is that. It's going to be this one, so I'm going to apply the sine angle difference. So in my formula, this will be alpha and that will be beta. So following that pattern, I know that this can simplify to sine of alpha minus sine of beta. Well, 100 take away 10 is just 90 degrees. So I know that whole expression simplifies to be the sine of 90 degrees, which I can go to my unit circle. There's 90 degrees. And I know that sine is my y coordinate. That's the sine of 90 degrees, which I can see has a value of 1. So the good thing about these questions is that I can always check them on the calculator. So making sure that I'm in degree mode, you can see I put my original value, sine 100 cos 10 minus cos 100 sine 10. I get a value of 1, which is the same as sine of 90. So I know that that is correct. Okay, in our second example, I have the product of 2 times sine and cosine of the same angle measurement. So those are the same. Looking on my formula sheet, that matches with a sine double angle identity where pi over 12 is alpha. So substituting that in, I have sine of 2 times alpha, which is 2 times pi over 12. So that would be sine of 2 over 1 times pi over 12, which when I multiply the numerators is 2 pi over 12. Now I look at my numbers, 12 and 2 have a common factor of 2, so I can simplify that to just be pi over 6. So 2 sine pi over 12 cos of pi over 12 is the same as sine of pi over 6. I can go to my unit circle and I see my coordinate for sine of pi over 6, and I know that sine is my y coordinate, so this should just equal to a half. So plugging that into my calculator, I can see that 2 sine of pi over 12 cos pi over 12 is the same value as sine of pi over 6, which is 0.5. So I know I've done that correctly. In my third example, I have a combination of coses with sines separated by subtract. So going to my formula sheet, I know this is either cos angle sum or angle difference. Looking at the subtract here, I know this is a cos angle sum. So this is alpha and that is beta. So I can plug that into my formula by doing cos of alpha plus beta. Then all I have to do inside is add those with a common denominator of 6. So times by 2 to the numerator and denominator. And now I can add those is 5 pi over 6. So using my unit circle, I'll go to 5 pi over 6, which I know is in quadrant number 2. Here is my point, and I know cosine is the x-coordinate, which is negative root 3 over 2. So I can plug that into my equation to see if I've done this correctly. I can do, into my calculator, cos of 2 pi over 3, cos of pi over 6, take away sine of 2 pi over 3, sine of pi over 6, has this irrational number, which is the same as the exact value, negative root 3 over 2. So I know I did that correctly. Okay, in my last example, tan of 15 degrees. Now, if I look at my unit circle, 15 degrees is not one of my nice points on the unit circle. So in this question, I'm going to use nice points on my unit circle to come up with an expression for tan of 15. Now, I can choose, for example, 45 and 30, subtract those. I could subtract 120 and 135. There's a couple that I could go around the unit circle and use. My tip to you is, wherever possible, stay in quadrant 1, because my sine, cosine, and tangent ratios are all positive in quadrant number 1. So I know this will be an angle difference because there are no angles I can add to get 15 degrees. So I am just going to go with 45 and 30 degrees. So I know that tan of 15 degrees will be the same as tan of 45 minus 30 degrees. Now, it's not as simple as doing tan of 45 and subtracting it from tan of 30. I have to apply my formula. So tan of 45 take away 30 is going to be, this will be alpha, this will be beta. Applying the formula, it's going to equal to tan of 45 minus tan of 30 all over 1 plus tan of 45 multiplied by tan of 30. So looking at 45 degrees, tan is the ratio of sine over cosine. Denominators are the same, so I just do numerator of sine divided by numerator of cos. So root 2 over root 2 is just 1. So I know that tan of 45 is a value of 1. Let's look at tan of 30. Again, it is the ratio of sine over cosine. Denominators are the same, so I'll do numerator of sine over numerator of cos, 1 over root 3. 1 over root 3, and I'll replace each of the 30 degrees with that. Okay, so what I really have here, if I tidy it up just a little bit, is 1 minus 1 over root 3 over 1 plus 1 over root 3. So to get rid of my roots, what I'd like to do is multiply numerator and denominator by root 3, because root 3 over root 3 is 1. I haven't changed the value of the question. So distributing this in, 1 times root 3 minus distributing this in, the roots cancel and I'm left with 1. In the denominator, root 3 times 1 and root 3 times the roots cancel. I'm just left with 1. So that means that tan of 15 degrees, although it's not on the unit circle, I now know using points on the unit circle and the angle sum and difference formula for tan is root 3 minus 1 over root 3 plus 1. Of course, I'm going to check that on my calculator. So plugging in tan of 15 in degree mode, I get this irrational number, which is the same as the exact value, root 3 minus 1 over root 3 plus 1. So I know I have done that correctly. So we've covered angle sum, angle difference, and double angle identity. We haven't covered why angles can't get loans. And the simple reason why angles can't get loans is because their parents won't co-sign for them. So I hope this video helped. If it did, please give it a thumbs up and hit subscribe so I can help more mathies just like you. Thanks for watching, and I look forward to seeing you for the next one.